Hello students, today we have to discuss a very important topic about the electronic spectra of transition metal complexes, that is microstate and term symbol for free metal ion. In this lecture we have to discuss what are microstates and how can we determine the number of microstates, what is term symbol and how can we determine the term symbol for free metal ion, and of course their application also. Now the first question is, what are microstate? In fact, you know that any electronic spectrum is observed due to rearrangement of electron in molecule or atom. In organic molecules, there is a available orbitals, that is pi bonding, pi antibonding, sigma bonding and sigma antibonding, non-bonding and pi antibonding, non-bonding and sigma antibonding, and therefore the transition of electrons from that lower energy level to higher energy level due to absorption of electromagnetic radiation results in the electronic spectra. But such type of pi bonding and pi antibonding orbitals are not found in the free metal ion, but they also give the electronic spectrum. In fact, if we consider, for example, that is the chromium 5 oxidation state, it is only one electron in d orbitals. It can be configured like in +2, +1, 0, -1 and -2. It means that their total 5 configurations are possible in this chromium 5 oxidation state metal ion. And if we consider the another 5 electronic configuration with the opposite spin, it means that there is total 10 electronic configurations are possible for that chromium +5 or D1 electronic configuration. Now you can consider the energy level of these 10 configuration. According to Schrodinger wave equation, you know that the energy of +½ electron and -½ electron are same, and we also know that all these 5 orbitals are degenerate orbitals. It means that the energy of +2, +1, 0, -1 and -2 are same, and therefore we can see that all these 10 configurations having same energy. In fact, each and every configuration, each and every unique configuration may considered as the microstate. Okay, and the energy of more than one microstate is maybe same, as in that example all 10 microstates have same energy. Now another question is what we know, that is how can we calculate, how can we determine the total number of microstate in such configuration. The total number of microstate may be considered by the following example. You know that the total number of microstate is considered as factorial of 2n divided by factorial of 2n minus r into factorial of r, where the number of electron is considered as r and the number of orbital is given by n. And therefore in such configuration, that is D1 configuration, we can see here the total number of microstate may be calculated as 10. And similarly we can also consider the different type of electronic configuration and the total number of microstate. Now another term is what? Term symbol. Term symbol is in fact represents an energy level in which more than one microstate belongs, and it can be represented as 2s plus 1 Lj, where S is what? The total number of total spin quantum number, that is summation of ms, and L is what? The total orbital angular quantum number, that is sum of ml, and J is what? The total angular quantum number, that is L plus S to L minus S. For example, if we consider the electronic configuration, that is P3 configuration, now we can calculate the total number of microstate in that configuration is 20 with the previous formula. And now these configuration may be seen here, that is there is +1, 0 and -1, and the electrons is occupied in these three orbitals. That is, if we consider there is no pairing electron is allowed in p3 configuration, only 1 and 1 configuration is possible. That is, you can see here, that is 1 plus half, 1 0 and 1 in minus half. And there is total S. It means that total S is what? Plus half and plus half, that is 1.5, and 2s plus 1 is given by 4 here. And another configuration is what? There is 2 electrons are paired and 1 remain unpaired. It means that the total S value is what? Half, and therefore 2s plus 1 is given by 2. You can see here the total L value is 0 here, for here, that is +1, 0 and -1 is equal to 0. Now total L value for that configuration is what? +1 and +1, that is 2 and 0. It means that total L value is 2. If L value is +2, it can be represented by D, and therefore another configuration is possible. You can see here, that is 2 electrons are occupied in 0 and 1 electron is occupied in +half. Total L value is what? 1. It means that another configuration is P. 1 is represented by P. It means that you can see here in P3 configuration there is 4D, 4S, 2D and 2P electronic terms are observed here. Now the number of microstate in these terms is 4, 10 and 6. That is 2s plus 1 into 2l plus 1. 2s plus 1 is 2l plus 1. 2s plus 1 is 2 and 2l plus 1 is what? Here 3, because L value is 1. Now 2s plus 1 is 2 and L value is here 2, and therefore 2s plus 1 and 2l plus 1 is 10. It means that total 20 microstates are maybe considered here in such type of terms. Now in next lecture we have to discuss how these terms are split and how can we consider, how can we explain the electronic spectra